Good afternoon, students. Welcome to the physics class. Today we will discuss about current electricity. And to start with, we will first discuss what is electric current. Well, electric current is defined as the rate of flow of charge. What we mean by this? Suppose through a conductor, if Q is the charge which is flowing in t seconds, then current is defined as Q by t. So current is the rate of flow of charge. What is the unit of charge? SI unit of charge is coulomb. And SI unit of time is second. So from this, SI unit of current comes as coulomb per second, or this is also known as ampere. So what do we understand by 1 ampere current? So 1 ampere will be given as 1 coulomb by 1 second. This means if 1 coulomb charge is flowing in 1 second, that constitutes 1 ampere current. So from this you get the definition of 1 ampere current. Well, now the question comes, what kind of physical quantity current is? Whether it's a scalar or a vector. See, suppose this were through this, for example, 3 ampere current is flowing. Another wire is connected here with this wire, through which maybe 4 ampere current is flowing, for example. And together they are connected with this wire. So what current will flow through this particular wire? It has been found that here 7 ampere current flows. Means these two get added. But current, the addition which I have done, it does not follow the law of vector addition. Directions are not being added. So this current is considered as, it's a scalar quantity. But there is a term called current density. What is that? Current density is defined as current flowing through unit cross-sectional area. It is defined as, it is noted by given the symbol small j, I by A, current by area. This current density, it is not defined through the whole conductor. It is not given throughout the whole conductor. This is calculated at a particular point inside a conductor. This quantity is a vector quantity. So current is a scalar quantity, but current density is a vector quantity. What is the unit of current density? Unit of current by unit of area. What is the unit of current? So ampere by meter square. This is the unit of current density. And dimension of current is A, and dimension of area L square. So it goes as A L to the power minus 2. This is the dimension of, so dimension of current density A L to the power minus 2, where dimension of current is 1 and dimension of length is minus 2. Let us discuss about the free electron model to get the clear idea about the charges which flow to constitute current. If we discuss about structure of an atom, my dear students, you have learned in lower classes about the structure of an atom, where we have seen that inside the atom there is a positively charged region which is known as the nucleus, and around the nucleus there are some certain energy paths in which negatively charged electrons move. For example, suppose here one electron and here one electron. Now the distance of this electron is less compared to the distance of this electron from the nucleus. So from Coulomb's law, what we have seen, force acting between charged particles proportional to 1 by d square, inverse square law. Means if the distance is less, force will be more. So as the distance is more here, so this particular electron, which is far away from the nucleus, is feebly bound. Compared to this is strongly bound. Means this electron is strongly being attracted by the nucleus, whereas this particular electron is feebly attracted. Now, if from outside I give energy to this electron in form of heat by rubbing or by heating, what happens with that energy? This electron comes out of the orbit and moves in the available space within the atom. And this particular electron is known as free electron. Okay? And these free electrons are responsible for carrying the charge in a solid. So they act as charge carriers. The free electrons. So in case of a solid, free electrons act as charge carriers. Now when this electron comes out, this atom becomes an ion. And there are few liquids and gases which are conductor. In that case, not free electrons but ions act as charge carriers. So, in case of solid, free electrons are charge carriers. In case of fluids, that is liquids and gases, ions are charge carriers, both positive and negative. Okay, so basic difference you have got between the charge carriers of solid and liquid or gas. Okay, next we will see what happens when an electron tries to move through a conductor. The density of free electron in metals is almost of the order of 10 to the power 29 per meter cube. Almost. A huge number. So what happens? Suppose this is the conductor. Through which the electrons are moving. So suppose this is the direction of electric field which is provided. So electron moves opposite to them. In this direction, electrons are moving. Now, as you remember, when I told that when electrons come out from an atom, it becomes ion. So inside the conductor, there are free electrons as well as some stationary positive ions are also present. When these electrons try to move from one side to another side, there are some positive ions with which these electrons collide. So the speed with which, the velocity with which it was moving, why it was moving? Because when you have applied an electric field, that is the potential difference you have applied, the charge which was moving, it experiences a force. If suppose E is the charge of an electron, which is applied by an electric field E. So the force which it experiences the amount of charge into electric field, intensity of electric field. So with that force, it starts accelerating. Now when it starts accelerating, what happens? It collides with the positive ions which is present. So its speed or velocity decreases. So constantly it cannot move. And this is what the resistance is offered by a conductor. Means this is the restriction, or these are the constraint in path of flow of electrons. Now the path which is travelled, or the distance which is travelled by an electron between two successive collisions. Suppose here it got collided once, and secondly here it is getting collided. So the path which is travelled between two successive collisions is called free path. And the time which is taken by an electron between two successive collisions is known as relaxation time. Another thing, when if you have applied, normally free electrons move with a velocity in the order of 10 to the power 5 meter per second. When you apply the electric field due to the collision, what happens? Number of times it gets collided with the positive ions. So basically the potential difference which I have applied, it does not give acceleration to the electrons, rather it gives a very small constant value, velocity to the electrons with which they move. And that small constant velocity of the electrons are known as drift velocity. Which is of the order of 10 to the power minus 4 meter per second. So very small constant value. Okay. So these are few terms which you need to know. The definitions of these particular terms and what are they. See, you need to clear the basic concept here. Otherwise, you will face problem in the future discussions. So clear your concepts here. What are the things? Well, in the next topic, I am going to discuss about the thermal velocities of the electrons. What is the average thermal velocity of electrons? Suppose there are n number of electrons which are moving. For example, let us consider that the thermal velocity of first letter U1, U2, U3. So it goes like Un. So what is the total thermal velocity? U1 plus U2 plus U3 plus Un. And what is the average thermal velocity? Total by number of electrons, that is N. And this comes as 0. Why you know? Because after every collision, electron changes its direction. So suppose it was going in this direction, it got collided here. So it changed its direction. Again there is a positive ion. Again direction change, positive ion, direction change. So the directions are changing after each collision. That's why the average thermal velocity of the electron is 0. From this calculation, this will be required. Suppose if there are n number of electrons which are moving, charge of an electron is E. So what is the total charge which is flowing? There are n electrons, total number of electrons which are moving, that is n, and charge of a single electron is E. So what is the total charge given by Q? That is n into E. And if this flows in T time, so the current is n into E by T. This is also being calculated like this. Okay. And you know very well the value of E, you know here, 1.6 into 10 to the power minus 19 coulomb. From this, how many electrons are there and what is the time taken? Time is taken in seconds. You will calculate the current. You can calculate. Another thing, 1 ampere current means how many electrons? See, charge of an electron is 1.6 into 10 to the power minus 19 coulomb, as I said here. So this much charge is present in how many electrons? In 1 electron. So 1 coulomb charge is present in how many electrons? 1 divided by 1.6 into 10 to the power minus 19. If you calculate this, it will come as 6.25 into 10 to the power 18. 6.25 into 10 to the power 18. That means 1 ampere current can also be defined as 6.25 into 10 to the power 18 electrons moving in 1 second. In place of 1 coulomb, I can also put the number of electrons, which is equivalent to 1 coulomb charge. I hope this is clear to you. Now let us see the relation between drift velocity and current. The drift velocity which I talked about, the drift velocity and current, what is the relation between them? Well, current is defined as charge by time. Now suppose it's a conductor which is flowing. If we consider this to be the cross-sectional area of the conductor, that will be A. And the electric field is given in this direction E. Electrons are moving in this direction with the drift velocity Vd. Okay. So what is the total charge flowing? Let N be the number of electrons per unit volume, A be the cross-sectional area, E is the electric field, and Vd is the drift velocity. Then N equals to, means number of electrons per unit volume, so charge which is flowing, Q will be equal to, or charge of an electron, E. So N into E, and area of cross section A, velocity Vt. Okay. So from this, I into T, if T seconds it flows, V into T. So I is Q by E. So N into A into Vd into T divided by T. They get cancelled out, and what we get in A into A into A Vd. So this is the relation between current and drift velocity. From this, if we talk about current density, J equals to I by A. So what we get? N into A into A into V divided by A. So N into A into V. But if we want to write it in vector form, so J vector equals to minus A into V. This minus sign symbolizes that the direction of flow of electron is opposite to the electric current. Opposite direction. If you go by the conventional direction, that is charges, they are at negative potential, they move towards the positive potential, that is from negative to positive, and electric current is in the opposite direction of that, that is from positive to negative, higher potential to lower potential. So I hope this one is clear. Well, next which I am going to discuss is the resistance. Next topic is resistance. Now from the electron model, if you remember, I already talked about this particular term, that the collision between the positive ions and the electrons is actually the main cause of this particular term, resistance. Resistance is defined as the ratio of potential difference divided by the current flowing through the conductor, V by I. How it is defined? according to Ohm's law, the potential difference applied across the ends of a conductor. So suppose here this is the potential difference which is being applied. This is the conductor. Suppose V is the potential difference and I is the current flowing. Then according to Ohm's law, the potential difference applied across the ends of a conductor is directly proportional to the current flowing through it. So V proportional to I, provided the temperature and all other physical quantities or physical conditions of the conductor remain same. Means if the temperature, length, area of cross section like this, physical constants are present inside this conductor, then V is proportional to I. So physical conditions remaining same, potential difference directly proportional to current. So from this, if you want to remove this proportional sign to equal sign, you have to give one constant and R is that constant. And that is the resistance, V by R. What is the unit? So volt, this is the SI unit of potential difference, divided by ampere. This is known as ohm. Okay, volt per ampere, ohm. So from this, you can also define 1 ohm. See, 1 ohm, definition of 1 ohm resistor. This is the symbol of ohm. So 1 ohm equals to 1 volt by 1 ampere. This means that 1 ohm is the resistance offered by a conductor which is applied by a potential difference of 1 volt and carrying a current of 1 ampere. So if 1 ampere current is flowing through a conductor whose potential difference is 1 volt, then its resistance is 1 ohm. Let us check the dimension of resistance. How to find out? In case if you have forgotten, I am just giving a quick recapitulation of that. So suppose volt, ohm, unit, volt by ampere. Volt means what? Joule per coulomb. By ampere. Ampere means current. Well, now see. Joule means Newton into meter. Divide by coulomb. Coulomb means what? If you remember from here, 1 coulomb by 1 second equals to 1 ampere. It was there. So coulomb means ampere into second. And another ampere was here, so ampere square. Now Newton means kg meter to second square. Kg meter per second square into meter by ampere into second. So what is coming? Kg meter square by ampere second cube. Now see, you have got the unit of mass, length, current, time, fundamental units you have got. So the dimension from here I can write. Kg means it denotes to mass. So m, meter means length, L square, current remains same, A is the dimension, so A minus 1, and second time it is equal minus 2. This is the dimension of resistance. I hope it is clear to you. Okay. Next, I will discuss about the factors on which this resistance depends for conductor. See, first, from Ohm's law, what you have seen. So, if there are two types of resistors, one is ohmic and one is non-ohmic. if I take these IT characteristics, one which is ohmic will be like this, the graph for ohmic conductor. Means the slope of this graph gives you the resistance, value of resistance. From this slope you can calculate. But wherever you take the slope, while at this point or at this point, the value of R remains same. So the value of R is actually independent of V and R in case of ohmic resistor. It is independent wherever you take, because if V increases, consequently I also increases, so the ratio remains same. Another one is non-ohmic, like diode valve or triode valve. What we get there, suppose like this you can get. It is not set. So this is for non-ohmic, which does not follow the Ohm's law. One which follows the Ohm's law is ohmic, one which does not follow, non-ohmic. But in case you see, the slope here will be different, the slope here. So what happens, here the resistance is constant, but here the resistance is dynamic, it changes. Means this R, delta V by delta I, this value changes from point to point. So this is dynamic resistance in case of non-ohmic resistance, and in case of ohmic resistance you get the constant resistance. Now there are few factors on which this resistance of a conductor depends. First, it is directly proportional to the length of the conductor. What is that? If this is a conductor, suppose this length is L1 and there is another conductor, same material, both suppose copper, its length is L2. So as L2 is greater than L1, so the resistance of the second conductor will be more than that of first conductor. Okay? It is inversely proportional to the area of cross section. What is that? This is the conductor. This is another conductor of same length. Here L1 is equal to L2. But this area of cross section is A1 and this area of cross section is A2. So as A2 is greater than A1, so if area of cross section is more, it will be less. So R2 is less than R1. Clear? If we combine these two laws together, so R proportional to L by A, from this R proportional to one constant into L by A. This constant is known as specific resistance or resistivity. This is specific resistance. Okay. So what is the unit of specific resistance? What will be the unit of this? So rho equals to R into A by L from this equation. So ohm, area means meter square, length means meter. So ohm meter. Here. And opposite of this rho is known as conductivity, 1 by rho. Okay. Conductance. So that is what we will get. Rho equals to R A by L, so it will give L by R into A. Unit is ohm inverse, meter inverse. Also this is known as Siemens. Okay. So this is the unit of specific resistance and conductance. Fine. Now from this, if I ask you that suppose there is a short numerical type question, from this concept I am using that. keeping the temperature constant, if I double the length of a conductor, what will be the new resistance? Suppose the length of the conductor gets doubled. So if the length of the conductor gets doubled, the same conductor, area of cross section becomes half. If you stretch a wire, its length increases, but as well as the area of cross section, the thickness decreases. So suppose the length of cross section, length is L and area of cross section is A. Now as the material remains same, the specific resistance or resistivity is the property of the material. So rho remains constant whether you stretch it or you contract it. So suppose the resistance is R1, that will be rho into L by A. Now, as per the new condition, the length is doubled. So L, new length L1 has become 2L, that will be R only. And new area A1 has become A by 2, half. Because if you increase the length to its twice, double of its length, then the area of cross section will become half. So the new resistance R1, rho remains same because the same material, so it does not change. So now in place of L, I write 2L, in place of A, I write A by 2. So it comes as 4 into rho L by A, so 4 into R. So the new resistance is 4 times the previous resistance. Similarly, if the area of cross section gets doubled, length becomes half, you can also calculate from that. I hope this is clear to you. Okay, so this is for the day, my dear students. Next day, my next class, we will discuss more topics. Till that time, take care.